This last question then, question number 14, is a two-proportion z-test. So we're looking for evidence that pain reliever A is more effective than pain reliever B. So the effectiveness of pain reliever A, 221 out of this total size that took pain reliever A, that's 500. Same thing, we also have 500 observations for pain reliever B. That's important because we're going to have to enter those into the calculator in just a second. So we're looking for evidence that pain reliever A is more effective. So we're looking for evidence that the population proportion subjects that would indicate A is more effective is greater than B. So if we look at their difference, the null hypothesis would be that the difference is 0. The alternative is that the difference between the proportion of A minus the proportion of B, we're looking for evidence that that difference is positive. So it's important in the calculator, if we're going to take the proportion A minus the proportion B and look for a positive alternative, we have to put in the data for A first and the data for B second into the graphing calculator. So we'll go to Stat and over to Tests. We'll select the two-proportion z-test. That's option number 6. So again, we have to enter A first. So for A, there were 221 that said yes to A. The number of observations is 500. For B, we had 198. And the number of observations there is 500. Because of the order in which we're subtracting, this is a greater than alternative. So if we highlight calculate, again, that should confirm our z-score. There's the 1.474, and there's the p-value of 0.0702. Again, because this is a test involving proportions, when you're working with proportions, you're going to use z-scores, so you don't ever have to worry about degrees of freedom. When you're working with means, you're going to have to use t-scores, so with a single mean, your degrees of freedom is one less than the sample size. If you're working with two means, the degrees of freedom is more complicated to calculate, so you should copy that off of the calculator screen. The other test, and you do need to document those degrees of freedom on the AP exam. When you're working with a chi-squared test, that also has degrees of freedom. Again, you want to document that. So the chi-squared test, the degrees of freedom in a goodness of fit test is just one less than the number of categories. In a test for association or independence, or in a test for homogeneity, the degrees of freedom would be the number of columns minus 1 times the number of rows minus 1. And the only other test where we would have degrees of freedom would be in a linear regression t-test or a t-test for slope. And again, in that case, you want to make sure to write down your t-score and your p-value and your degrees of freedom, which for the t-test for slope, the degrees of freedom is 2 less than the sample size.